Hi everyone, welcome to my channel Tech Binary Sphere. So today I am going to use a hardware that is USB logic analyzer. It is a very small and very useful thing for the electronic purpose in if you are working for digital signals, and it is very affordable. You can purchase in around $5, or you can say under 500 rupees at present. So let's talk about this. It is having some pins which you have to connect with the Arduinos, and here is the connection which you have to connect with the USB cable via to the port. So in this, I am trying to debug the data from the Bluetooth to the Arduino or Arduino to the Bluetooth. You can say RX and TX. So this will be like this. I have sent the data from my Arduino to Bluetooth. That is, please subscribe. And one more thing, please don't forget to subscribe. You must subscribe. You can see here, I have sent the data. Please subscribe. So let's start USB logic analyzer. So the agenda of this task is to tell you about USB logic analyzer, the comparison between analyzer and oscilloscope, about its software IDE, and in this task we have a project that is debugging the Bluetooth data which we are sending from mobile to Arduino IDE serial monitor and vice versa. And also I am going to tell you about the connection. So in our college or in office, we somewhere have used oscilloscope or have seen, but it is much expensive that we can't buy for ourselves for our DIY purpose. So I'm having a device from that you can come out of the box. It is most affordable than the oscilloscope and can perform digital signals and explore many things. Oscilloscope, somewhere we have used this in our laboratory or somewhere. It is having a sine wave, and this is the USB logic analyzer. So let me introduce you USB logic analyzer. So on the hardware, it is showing 1357 or 12345678, and in the bottom clock and ground. These both are ground pins, and in the simulator it doesn't start with channel 1, it starts with channel 0. So please consider your channel 1 in USB logic analyzer will be the channel 0 in simulator. So the comparison between oscilloscope and USB logical analyzer are as follows. Oscilloscope is used for capturing and analyzing both analog and digital signals, but in USB logical analyzer, it is used for capturing and analyzing digital signals. In oscilloscope, it captures and displays voltage over time. In USB logic analyzer, it captures multiple digital channels simultaneously. The third point of the oscilloscope is it provides detailed view of waveform characteristics such as amplitude, frequency, rise time, and more. So in USB, it provides a time correlated view of digital signals and their interactions, and it decodes digital communication protocols. The fourth point of the oscilloscope is it has higher sampling rate, often in the gigahertz range, allowing for detailed analysis of high speed signals, but it is opposite in the USB logic analyzer. It is having lower sampling rate compared to oscilloscope, usually in the range of megahertz. Oscilloscope, it displays waveform showing voltage level and signal shape. But in USB logic analyzer, it shows logical state, high, low, over time, and can display binary or hexadecimal data. Oscilloscopes are generally more expensive than logic analyzers, especially high-end models with advanced features. But USB logic analyzer is less expensive than oscilloscope. So after connecting the system or your PC, there will be two LEDs which will be on when you connect. First one is your power and second one is your channel. Somewhere it is written as ground or something else. So before starting the data debugging between the Bluetooth and Arduino, we have to do some setting in the Logic Analyzer's IDE. And before starting IDE, I will tell you few things of this device, that there is a two side. Left side it is written channel 1357 and clock, and right side channel 246 at ground. In some devices it is also written ground as clock. So if you are using right side, then connect your ground to right side, and if you are using left side, then connect your ground to left side. So this is the software, and I'm using a beta version of LA Logic, that is 1.2.29. So at present it is showing disconnected. You have to connect your USB. So when you connect your USB to the port, so in the left side it is showing some channels, and there is a start button that you have to press after connecting all the wires at the time of sending data. So let's start these channels to work. You have to click on analyzer, then click on asynchronous. Then you have to select the serial channel. Which one? I'm using channel 1 for the RX part or a TX part that I will connect later on. Then you don't have to change anything, or if you want to change as per your date, you can change. Then click on save. Then here on the left side you can see on channel 1 it is showing asynchronous serial. And in the right side you can see an option async serial. So we need one more channel for your TX part. We have to do same thing. Now we have to select a channel. I'm using channel 3 because our right side of all the pins. One more thing, click here, use auto baud rate, and then save. Let me edit. Now this is the analyzer part. Now click on the option. So here is the ASCII and hex, binary value, decimal value, and hex value. That I will show it later on when we are getting the data. So this is the code in the Arduino which we are using for sending or receiving the data, and we are also using an application that is serial Bluetooth. So we can send a data also from the serial Bluetooth application to the serial monitor and serial monitor to the application. I will add the screenshot of the application, what data I have sent. So as I have sent a data from serial Bluetooth application, the data is welcome. You- So you can see here the data that is welcome. And one more thing you have to remember, that it so if you want to read the data, you don't have to read from left to right side. You have to read the data from the you have to read the binary values from the right side to left side. So here we are getting decoded protocols. The data is welcome. Please avoid R and N. These are some kind of error or space error. So this is our data. So here we are getting the ASCII value. We can also change these data. Just click on option or big values, binary values. The values are 0B, 0 1 1 1, 0 1 1 1. Same like here. This is the 0 1 1 1, 0 1 1 1. So this is the binary value of all words, that is welcome, WELCO. Also change the data to our decimal. This will be like this. We can also change it to this will be like this. So let's have ASCII value and hex value same. This will be like this. So the same data we have received in the serial monitor of the Arduino. So I have sent this data, that is WELCOM. TX part is done. Also debugging of TX part of the Bluetooth is done. Let's have RX part. So for RX part or for debugging the RX part, what we have to do is to send the data and you have not clicked on the start button, the data will not appear here. So click here, the start button, and then so from here I'm sending data. Please subscribe. Spelling may be different. So after pressing the enter, forget to click on start button first here, then go to your Arduino and press enter. So the data will occur there. So yes, we have successfully debug the data between the Arduino and Bluetooth. You can see. Yes, you can check it. It is a please subscribe here. The data will be like the SI value. Let's change it to the another to SI and hex value. This will be like this. The hex value of the P is 0x70, or you can change to binary value. It will be like this. So the value of P is 0111 and the last four values are 00. So in if you want to read the value, you have to read from the right to the left. Like here is 0 and the 111 is the high value and all the four values are 0. Click on L. So if you click on A, then this will show. Not only the part of Bluetooth, you can debug. You can also debug I2C protocols value, SPI, and more, CAN, and more and more. And more. You can explore as much as you can. So this not will be the last project. I will have STM32 Nucleo board. I will try to debug more things from that board.